Okay, well, welcome everybody to the next Scholars Talk of the Evo-Devo Universe research community. We are honored to have Bob Doyle, the information philosopher, who's been a long-time member, and he's going to give us a talk about information and physics. And Bob, we were just talking about just how inspiring you are and your website. 89 years young, you have done so much with what you've put out already, and you said you've got 5 books planned. Is that correct?
I have 5 books mostly written on this website. This website is enormous. It has thousands of pages, and I have 5 books with another 5,000 pages, and I'm planning 5 more books under different topics. If I go here, you'll see I have a drop-down list. Oh, well, I'll show you more about them later. And I have arranged my website to be into various topics, like all the problems that I started off with in the beginning, the issue of free will, the question of values in the universe. I have this strange idea called ergo, which is ERG 0, or free energy, gives free energy. I have a lot of work on how knowledge comes about, how we know things. I have a lot of work on life itself with topics you guys are all talking about. I have a model of the mind, which is purely biological. I have a lot of bit of a work on chance, a great deal of work on quantum physics. My thesis was PhD in quantum physics. And the problem of entanglement, which some of you may have heard talk about, these Einstein spooky action at a distance. Mm-hmm. I've studied the work of John Bell and have a lot of work on John Bell and a plausible explanation of how this works for those who want to dig into the quantum physics. So anyway, we'll have a lot more to say about this once we start. So.
Well, we are now after the hour. The floor is yours, sir. And just really looking forward to seeing where you're going. We've got 90 minutes. Hopefully, we can get to questions in the last 30 minutes, or whenever you feel is appropriate. If you want them during the presentation.
Yeah.
Again,
sure. Let's start. And nice to see Jim Kaufman, who I've been getting some help on writing up my webpage on Stan Salty, who I read a good deal and had just a little bit going on his work. And now I've gotten another book recommended by, I can't seem to locate it here, but the one you recommended, Jim, Evolution and Development. And I'll be working on that and adding to my page on Stan. In every case, if you look up, scroll this page up a little bit, you'll see that I have over 500 philosophers and scientists that I've read in the last 70 years, and I'm scrolling through my presentation, which you can find on the web when we're all done. And basically, I've got all of these people that I've been thinking about. So I do that when someone's alive. I always contact them and say, I'd like to write a page about you. Would you please help me get it right? Because as a former software developer, I basically know that the best user experience comes when you debug all those problems and you get this good stuff out there. Okay, so I'll just, I guess, start at the top of my talk here and tell you that when I came to Harvard in 1958, I had studied physics at Brown, great teachers, read a great book called The Nature of the Physical World. You may all be familiar with it. It's one of the great books to know about, by Arthur Stanley Eddington. It was based on his 1927 Gifford Lectures, which were just before Werner Heisenberg announced the uncertainty principle. And in the Gifford Lectures, Arthur Stanley Eddington said, it looks as if the physics of the world is committed to determinism, that there's a great single set of laws controlling absolutely everything. But by the time he got around to publishing the book called The Nature of the Physical World, which is a year later in 1928, he said, oh my goodness, uncertainty principle, indeterminism, wow, that opens up a little chink in the problem of free will. I've been running with that chink ever since, John. I am basically worked out 2 or 3 ideas of Eddington's with the help of one of my mentor, I'll explain. And one of them was free willed. So our great interest, of course, is in the entropy law, the second law of thermodynamics. And what Eddington said was, listen, this law isn't like all the other physical laws, like Newton's laws, right? It isn't time reversible. For another thing, it has qualities, he said, unlike any other physical quantity, things like beauty or harmony, maybe something like good and evil, I thought, and I've been running with the idea ever since, that negative entropy is very badly named. It's not negative at all. Another way of looking at it is free energy, and it is definitely something positive. And so I decided at the time, maybe I could come up with a better word for negative entropy, and I chose ERG, E-R-G, with a subscript 0, which is free energy, gives free energy, G0, and I've been playing games with the name ergo and the air god, if one wants to go in that direction, ever since. I'm going to then say, at the time I arrived now, I was just, 20s. I asked my professors at Harvard one big question. We say the universe began in a state of thermal equilibrium, right? Maximum entropy. So how do we have so much information in the world today? Only 2 of my professors took me seriously. I asked a lot of people, and I got a little buzz out of that. One was David Laser. He spent the rest of his life on this problem, and I've been reading philosophy and physics for 70 years to explain it, okay? So I'll come back to the main thought we've got here today. Does the universe develop and evolve? Of course it does. We study cosmic evolution, Eric Chasen's book, including galactic evolution, stellar evolution, and planetary evolution. Now, planets, stars, galaxies, and the universe itself are all complex systems, and complexity science studies all of them. And since George I's satellite meeting on complexity science last week in Siena, which, because of an exchange with him on our list, he invited me to come. I had hoped to meet Paul Davies there. For years I've been thinking about him and influenced by him, and I've drafted a brief history of complex systems, showing how Davies turned the Santa Fe Institute toward theology and to teleology. Now, I don't know if you know the background of George Cohen and the founding of the Santa Fe Institute, and how in 1999 Davies came and set up that book called the Complexity Life book. This is a key book in the history. And then, of course, a few years later, Davies followed up with Gregerson and this book on information and the nature of reality. The story is really all there, and I hope to pursue that more in the future, okay? Of course, life is also a complex system, but I want to discuss what I see as a vital difference between living things and the abiotic universe. And that difference is the role of information, which is why I think of myself as the information philosopher, okay? The universe and its galaxies and stars and planets are all rich in abstract, immaterial information. Try to roll this up near the top a little bit. But this immaterial information needs matter to be embodied into something, and it needs energy to be communicated. And how it gets embodied and how it gets communicated is critical to what's going on in evolutionary systems. I'll see. So all the objects in the universe, I want to say that to be communicated means for scientists to observe and to measure that information. So all the objects in the universe are concrete, not immaterial, concrete material information structures composed of matter and energy components. You know, the quarks, gluons, electrons, and photons present at the origin, although the atoms, molecules, and macromolecules of interest to us in life couldn't be stable until the universe cooled to the current surface of the sun, around 3,000 degrees, 6,000 degrees Kelvin, around 380,000 years after the origin, something we now see as the cosmic microwave background, cool down to 2.7 degrees Kelvin. So non-living objects like atoms, molecules, planets, stars, and galaxies are passive information structures. They're entirely controlled by fundamental physical forces, the strong and weak nuclear, electromagnetism, and gravitation. As I see it, these objects do not control themselves. They are reducible. This is the reductionist view that everything that comes up, bottom-up forces on absolutely everything in the universe. They aren't acting, they are acted upon. But you and I, living things, are active, dynamic, growing information structures. We're forms through which matter and energy are continuously flowing. And it's top-down communication of biological information that controls all those flows through our bodies and so forth. Now, the fundamental laws of thermodynamics apply to both living and non-living systems. The second law says that entropy must always increase, suggesting a heat death for the universe, something I've seen mentioned on the Evo-Devo talk lists from time to time. It also suggests the universe might have begun with a vast amount of information, since increasing entropy has been decreasing information since the origin, and there's so much around today, including you and all of us, and as our wonderful work goes on here on Earth. But anyway, I want to show how the universe began with a bare minimum of information, and I also explain how it avoids that heat death that some of us have been worrying about. So first, we need to consider Laplace's demon. You probably all know Pierre-Simon Laplace, the great probability theorist developer around the turn of the 19th century. And he knew Newton's laws of classical mechanics extremely well, did a lot of work in that field. But he imagined this famous intelligent demon who knows the positions and the velocities of every particle in the universe. He also knows the forces on all those particles, and using Newton's laws, he can therefore calculate the positions and velocities all the way back to the beginning and into the indefinite future. He could know the entire past and future of the universe. In that case, information would be a constant of nature, which I plot as a blue line in the diagram on the demon below. I want to note that my MIT colleague, Seth Lloyd, thinks information is a conserved constant, like the conservation laws for mass or energy. Bob is nodding his head no. You don't think he does? Or you don't think it's right? Yeah, never mind. I'll go on, and I hope you'll get back to me on any questions later. But okay, so he thinks it's conserved information, just like mass and energy are conserved. He also thinks the universe is a computer, and there are a very large number of his associates in physics and many in problems of the human mind that think the mind is a computer, just like the universe. I'd like to get back, done a lot of work on that. It's sort of off topic, but I'm glad to get back to it later if you're interested. So here's the diagram. You can read this later. We've mostly told the story. But now this flat line constant information quickly got a new look, because midway through the 19th century, Lord Kelvin, who invented the absolute temperature scale of Kelvin degrees, and the second law of thermodynamics had just been developed, and it requires that information cannot possibly be a constant. It would have to be destroyed as the entropy irreversibly increases. And Helmholtz described this as the heat death, and the picture then became something like this, that the universe must have started with a very large amount of information, and then it would have declined with the increase of entropy and go down and down and down, heading towards the end of the universe with no information left in it. Okay? Now, Kelvin's claim of a heat death, let me pull this back down, would be correct if the universe were a closed system. And as you know, we today don't think the universe is closed. It's open, it's infinite, and there are some, like me, who think it may have always been infinite. It did not start in a point and expand with the inflationary theory of Alan Guth and so forth, but it has always been infinite, and it was at a time, very, very, at the beginning, an extraordinarily high density. So we're going to show how an open universe can actually create negative entropy locally to avoid thermal equilibrium. Now, in this famous 1944 What is Life article, Erwin Schrödinger famously argued that life feeds on negative entropy. Now, Schrödinger's source for the negative entropy was our sun. With the bright sun as a heat source and the dark night sky as a heat sink, the Earth is fundamentally a thermodynamic engine, and it's running something. Now, the picture I have here is that the sun, now a bright spherical, beautiful circle, must have begun as a cloud of dust and gas that collapsed to this condition, and we need an explanation for how that happened. But in any case, the high energy temperature of the light gets thinned out in energy density as it travels to the orbit of the Earth. And here, where we have an average temperature of that energy at around 300 degrees Kelvin, that's our average Earth temperature. And as the Earth spins and goes around to the night sky side, it radiates away. That's the heat sink to the cosmic microwave background all the way. So we have the ability to run this engine. But I want to point out that Schrödinger didn't know how the sun came to be such a source of negative entropy. That's a problem for cosmology. And we need to explain how a universe beginning in thermal equilibrium with maximum entropy can create this spherically symmetric star sending a stream of negative entropy to the Earth. Now, Eddington, who I'd point out here, was the great scientist who proved Albert Einstein's general relativity theory that space is curved. He went personally and headed an eclipse expedition in 1919. And the thing that made Einstein famous, Einstein is famous to us today, but it was Eddington who put his name on the map around the world. Eddington himself then, I have found, and David Laser has found, suggested in 1934 that the expansion of the universe, which had been discovered just a year earlier by Edwin Hubble, in 1927, might create new cells in phase space, that is to say, velocity times position or momentum position space, faster than the particles can themselves randomly fill those cells. There are lots of more possibilities than there are particles. All of a sudden now there's a chance, it's not necessarily anything that's programmed to happen, that they would fall into new arrangements which would be local, what I call pockets of negative entropy back in the day. But notice that could only be the case if the global entropy elsewhere is increased even more than that negative entropy increase in order to satisfy the second law of thermodynamics overall. So that's where I've been working on this, and so is my Harvard mentor, David Laser, who developed this idea of Eddington's, that the universe might be expanding faster than the particles could get them back into an equilibrium state. So we're running away from that maximum entropy. Basically, Laser showed that the maximum possible entropy of the expanding universe increases much faster than the actual entropy increases. So disorder entropy and order, negative entropy, are both increasing in the universe, according to Laser's view. And now I helped Laser with his book. My wife and I both read every draft of the thing, and it was a great experience, and he was a wonderful person to work with. Anyway, I adapted the diagrams in his book. There you go. Thank you for that, John, because I don't think he, in the end, explained it as well as I've tried to do in this one compact diagram that I've got all over the web. There's lots of references to this now. We don't need to read this now because the basic thing we need to see is the universe doesn't start at the top of the information column. It starts way down here at the beginning. And basically, it moves on up. I see you can't see my mouse as well as I can, but I hope you follow the idea. The universe expansion going faster than the entropy can get, the particles can get re-equilibrated, is going up slowly. Whereas the maximum possible entropy is going up much faster. It opens up this range in between where we could have negative entropy forming and possible information, including all those galaxies and stars and planets could form in that space. So you can see there's plenty of room for galaxies, stars, and planets. Now notice that the information, that the universe didn't have a lot of information at the origin, right? And it also didn't have the same information that it has today, which Laplace and Seth Lloyd seem to think. And I repeat there something I said earlier. The expansion of the universe, therefore, literally creates new space. There was a famous theory by Fred Hoyle that the universe could create new matter so as to keep the density of the universe constant in what he called a steady state universe. No, but we can say that new space is being created, even if, notice, the universe was and is infinite. It's just that it's getting more infinite in this theory. Now, I decided that I decided to call this the cosmic creation process, based on Eddington's and Laser's insight into the growth of order in the universe. So my cosmic creation process is the first of 4 examples of random possibilities coming into existence, being created, that can then lead to new information in the universe. And the others, I'll try to talk about them just a little bit. One is Claude Shannon's communication of information. I think I talk about it a little more below. My freedom of the human will, it turns out in the 1970s, I came up with an idea on that. I'll discuss more about it, and Darwinian evolution. I chose to call all of these 2-stage models. They must start with possibilities and then go to an actuality. Okay, we'll look for that in all the things we're doing. In the first stage, some new possibilities randomly, and this is key, appear. And in the second stage, one of them becomes actual. So let's go to biological information and its communication. And I want to give credit to Erwin Schrödinger again in that What is Life article. Terrific article. It's only like 10 pages. Really, I've read it at least 4 or 5 times he gets it crazy on a few things, as you know, but it's a wonderful piece of work. He explained how genetic information could be stored in the atomic structure of a long molecule, or what he called a periodic crystal. Of course, a periodic crystal, if it was just periodic, would be nothing. But Schrödinger already had the sense if that crystal had different things along it, it could carry some kind of code, which later on, just 9 years later, Jim Watson and Francis Crick in 1953 found DNA. Now, I want to point out that just 3 years before that genetic code was discovered, Shannon had formulated his theory of the communication of information, describing digital bits. He said that the amount of information communicated depends on the number of possible messages. With 8 possible messages, one actual received message would communicate 3 bits of information. That's 2 to the cube is 8, and so forth. And here's a very important thing. If there is only one possible message, there is no new information. So this, again, this is my field, my work. We have to say possibilities are necessary for information to come into existence in the universe. And this corresponds to the deterministic view, and there are still a surprising number of physicists and philosophers who are really comfortable with the idea that everything is determined. It sort of fits in a lot of ways with bigger pictures, like someone behind all the laws, someone behind all the determined events. But it is a view that there is only one possible future. Both that future and the entire past completely predetermined from the beginning of time, and the total information in the universe as a conserved constant, as many physicists and some world religions believe. This is a comfortable picture to a lot of people who want to think, well, if anything's happening wrong, I'm not responsible, or other sorts of things that a deterministic view, like the book by Robert Sapolsky, the new book is really interesting. He makes a good case for explaining away problems with human affairs that need to be explained away so that we don't feel like the whole weight of everything is on our shoulders. Anyway, coming to the problem of free will, again inspired by Arthur Stanley Eddington, who suggested in 1928, as I said in his book version of the Gifford Lectures, that Heisenberg's uncertainty principle could put a chink in determinism. And from that time, David Laser and I debated about the free will problem. just a note. I gave David my book on free will, which was my first book in 2011. He said, well, Bob, you know, I'm still working on my book, so I'm not going to be able to read yours until I finish mine, but thank you very much. And then just less than a year ago, I got a call from Jean Laser, David's wife, who said he's died, and his manuscript on free will is on his desk. And Bob, she asked, is there anything you could do to help this? So a former graduate student of his who's out at UC San Diego and I got to be the editors and I publish David Laser's work on free will. It's just, I mean, isn't it wonderful, John? I see a thumbs up. It's closed the circle, hate to lose him, but in a way we ran this road together. So I came up with what I called a two-stage model of free will. And you see the two stages of possibilities followed by actualities. And I call them alternative possibilities, and they randomly come to mind. This is a key that the great William James in his philosophy, great book in the 1880s and 90s, said the mind was a blooming, buzzing confusion of lots of possibilities, and I buy into that. And in the second stage, an agent can make an adequately determined decision or choice based on morals, based on values, based on hopes and so forth. So researching over the years since, researching the literature, I've now identified many philosophers and scientists who propose that same two-stage model. And this is the way it goes, especially if you come into a field and it's been going on for a while. There's very little hope when you can have a truly original idea. I'm going to try a little funny thing right here. I'm going to click on this link, as you can always do, and I'll open another link. And I'll see if I can change to that link and see if it changes for you. And I see it didn't change, so I'm going to go back to my original one, which is right here. And there, okay. I'd like to be able to show you those things if we have time in the future. So over the years, I debated the problem of free will with many prominent people, notably the libertarian philosopher Robert Caine, who published the Oxford Handbook of Free Will and a couple of editions, managed to mention my work in that book, so that helped with what I was doing, and the very well-known compatibilist philosopher Dan Dennett, who died just a few months earlier this year. And a little side note there, when I heard that Dan had died, I immediately sent an email to Robert Caine, because the three of us had been debating for a long time. I had flown them up to a meeting at MIT and discussing this whole thing. And Bob Caine did not answer me. Very strange. I learned another day or two later that the two men had died within 2 days of one another. These guys I worked with for years are all both gone. One more wonderful thing, Dan Dennett, I got an email from one of my many correspondents on the website. Have you seen Dennett's video? And I won't talk to you about it now, but it's on his webpage, Dan Dennett, because he gave us about an hour or more long interview in which at the end, he basically says, Bob Caine and I were right that quantum indeterminism must have something to do with the randomness. Instead of what Dennett thought it would be adequate if it was computer randomness, pseudo-randomness. No, he finally agrees. Well, quantum physics is really important, and he mentions me, and it was just wonderful. He didn't send me a note or call me up and say, hey, Bob, I'm going to agree with you at this point, but I did find it from one of my readers. So now the two-stage model of evolution is basically, as you know, first possibility is actualities. And I want to quote Ernst Mayr, who, by the way, lived just 3 blocks from me, and I had the pleasure of visiting with him at his house once upon a time. And to me, he was like the version of the modern synthesis. At Harvard, he was telling the old story of everything is randomness. But he also said explicitly, quote, in his Toward a New Philosophy of Biology, evolutionary change is a 2-step process, which was very happy to me to read that. The production of genetically unique new individuals and the selection of the progenitors of the next generation. The important role of chance at the first step, the production of variability, is universally acknowledged. But the second step, natural selection, is on the whole viewed rather deterministically. And I've come to call it adequately determined. It's not determined from before you started thinking about things. And nor was the new species there already in a cosmic plan before it came about. And he says selection is a non-chance process. Now, I want to say that speaking of creation and creative processes, all complex adaptive systems are obviously creative. And the self-organizing autopoetic description of Umberto Maturana and Francesco Barella, who I've written about, describes them perfectly. But I want to argue that the self in a self-organizing Bernard cell is not communicating information. Whoops, I didn't mean to do that. So let's go back. Oh, it jumped me to the top of the page. So where am I? Sorry about that. We did that. Let's see. Yeah. No, it turns out I went to my home page. So let's find a way back to your page, and I'll just have to go all the way down to my bottom of my page. Oh, wait a minute. Sorry, guys. I think I have a link here to presentations, and at the bottom of my presentations, I should have this one. Okay, now I've got to find my way back down. I hope we're doing all right for time. Two-stage model of evolution, there's the quote. And so I just want to say, studied a lot complex adaptive systems, but since I view a Bernard cell as a passive information structure, one that in physics can be basically reduced. So the reductionist story is applicable to something like a Bernard cell. It can be modeled, and I met so many young kids at Georgi's group who are doing these complex systems models with stochastic and what's called principle of least action thinking, and they think they can work these things out, and they showed wonderful illustrations of things that look like they emulate penguins huddling in the Antarctic, ants crawling and along pheromone trails. The work they're doing in Georgia's group is really terrific and inspiring. But
hey, Bob.
Yes.
This is Jim. You're no longer sharing your screen. We're still on the Information Philosopher homepage. Is there any way you can?
Yes. Oh my goodness. Yes. Thank you very much for
Yeah,
that,
just
Jim.
stop. Thank you so much, Jim.
Yep.
Yeah. So this one and this one is not it. He's the beautiful. So I have to say share my screen. Now I'm going to go down to sharing the screen, and I hope it will tell me something like sharing this screen, but it doesn't.
If you look under the, do you see next to the red hang up button, do you see the 3 vertical buttons?
I do.
Okay, so if you click on those 3 vertical dots,
Yep.
at the top you'll see something that says cast this meeting.
I don't.
What do you see when you click those 3 vertical dots?
Adjust view, full screen, picture in picture, report a problem, settings.
Okay.
Okay.
Maybe what if you go to your what if you click over to presentations and then you go to your web page of that page? Can you do that?
I am on another screen here, and I've got my presentation there, but let's see. Go to the one that's Information Philosopher, and again, change it to presentations.
Yeah.
It didn't change, so I'll try this one. It's got to be one of these that's showing.
You're showing more than one screen currently, I guess, on your side, right?
I am, that's right. And I cannot get them to show up over here. So
what if you go to your sharing, the little laptop with the up arrow? Do you see
I've got
that?
it. Yes. And so it says stop sharing. Maybe I'll
do that.
stop and we'll start it again.
Yep.
And now how can I share? I'll go back to sharing.
Yep.
And I'll say this one. Share. Super. Thanks very much, John, for the help.
Absolutely.
Okay, now let's see if I can get down to where that one is over here. That's this one. See if it scrolls. I've got it again. Good. Thanks. Let's see. So we talked our way through most of this, and I'm coming down to my last word, so I'm doing pretty well. I thought I was shooting for a half hour. We're going to have a lot more time to discuss, and I'd love to drive around my website with you guys and show you what I've built for so many others who I hope will find it useful. So let's see. The Bernard cell is passive, and it's true, as Prigogine said, it's a dissipative structure, and those who kind of write whole large amounts of articles about Prigogine and his dissipation of energy and so forth just doesn't seem to me to get to the whole story. And he's enormously influential, as it's fine and should be, but I basically say a Bernard cell isn't alive. And finally, the autocatalytic processes that my friend Terry Deacon and others talk about, Stu Kaufman, is top-down causation of a sort, but it is not the forces, the causation that's going on, the downward causation of Don what's his name, Campbell or something. Anyway, is not. They're purely physical forces. So Bernard cells too are not alive. And as I see it, purpose, values, meanings, all these really big things you guys are very interested in. My view is that they all enter the universe when life appears. The only place in the universe, as we know, in the universe where life is known to exist is our biosphere. First named by the Austrian chemist Edward Suess in the 19th century as the interface of the lithosphere and lower atmosphere. And in the 20th century, the biosphere was made much more popular by Vladimir Vernadsky, who I've studied and find was the inspiration for Teilhard's noosphere. And today the biosphere is the locus of course, the great work of the Gaia hypothesis of James Lovelock and Lynn Margulis. And so I like to just say, as I'm winding up, if there exists an entity, and I had a kind of nice discussion with this with George I. and Sienna, if there exists an entity which has provided us with everything, the notion of providence, to which we should be thankful, even reverential in my view, it is surely our biosphere, which is our home in the universe. So I want to get my mouse over here again, move this up. I'm just reminding you what we've done. We really probably don't have to do this, but I guess we've got time. I introduced the cosmic creation process, which has these two stages or steps, alternate possibilities followed by adequately determined selection in the case of the will, or natural selection in the case of biology. I described how it doesn't violate the second law of thermodynamics and how we avoid the heat death. And I claim that this two-stage process can work on three great problems in philosophy: free will, Shannon's communication of information. By the way, many people think they don't believe there's a real connection between pure Shannon mathematical information and the biological, physical information, but there really is a strong one. And of course, the theory of natural selection. Now, I've made 4 more original contributions to science over the last 70 years, and they're all on my website. We may not have time for them today, but if anyone's interested, I'd love to talk about it. One is a biological model of the mind as an experience recorder and reproducer. It builds on an idea of the great neuroscientist Donald Hebb, who famously said that the neurons that fire together in an event coming to the brain, into the neocortex, those neurons that fire together get wired together, which later Eric Kandel explains in his idea of long-term potentiation of the synapse, and how that synapse that's wired in his Aplysia, the great snail, and they get, over the next few hours of having been wired, they get added protein to their structure and build up a system, a small portion of the neocortex, a random network of neurons. They build up we call today a Hebbian assembly. And so my extension of Donald Hebb's work is very simple. The neurons that were wired together by an important experience in our past will fire together if even any of them start to fire, because they're all connected. So he says neurons that fire together get wired together, and I say neurons that have been wired together will fire together and will re-experience, perhaps at a faded level, will re-experience that original experience. And what does that do for us? Well, it may be first that a new experience triggers off multiple Hebbian assemblies, in which case we've got William James blooming, buzzing confusion going on in our head, and we have to focus on one of them. But if we do focus on one of them, or two of them, or three of them, they become the alternative possibilities of my model of free will. And more than that, these multiple possibilities, first of all of the neural connections in the human mind are connected to the basal ganglia with the amygdala and the hippocampus, where all our emotions are being recorded. So that means that whenever we've had an experience in the past, if it was a pleasant experience, it comes back to us as something that was good. If it was fearful and horrible, it may come back with a lot of warnings, even putting us into a state of fear for the moment. But all of those, whether good or bad or indifferent, provide context for the current experience. So that the model I have of the mind is a situation that doesn't have any computers, no data processing, no central processor and data buses. Instead, it's just purely biology. And it's able to recreate the whole business of making sense of the past and giving meaning, in the sense of meaning we are all looking for, in terms of all those informations we lived through that come back to us and give us the meaning, give us the context of what it is we know. So the second problem I've worked on big time recently is quantum entanglement. I've done a lot with my quantum drop-down menu on the work of what Richard Feynman called the one mystery in quantum mechanics. How the hell does the wave function, which is just a purely abstract mathematical thing, control the motions of photons or electrons going those two slits of the two-slit experiment? How are they being controlled? David Bohm had a whole new theory of it, that there's another quantum potential acting instantly and so forth. I do with a lot of that on my quantum entanglement drop-down. And thirdly, my first few years at Harvard, I got kind of everyone joked about me as the guy who was talking about a flat universe and like a flat Earth theory. But it happened in 1959, my second year at Harvard, that a great astronomer named Walter Baade, who was a German scientist working at Mount Wilson during World War II, when all of his colleagues were being drafted into military intelligence service, this German couldn't work on military secrets. And so he had the Mount Wilson 100-inch telescope all to himself for a couple of years. And you know what? Not only did he have the time, the whole area was brownout time. Lights were all down everywhere. No astronomer, John, ever had such a good observing conditions. So Baade came to Harvard and he gave a wonderful lecture. I was in the lecture. And just before I learned what Baade learned, that the universe was twice as big as we thought it was. Basically, he found that the Cepheid variables in the Andromeda galaxy were a different population of stars, like we have two populations, and the universe was twice larger, 8 times more volume. And what had happened at that moment for me, you all remember the idea that, maybe you're not all as old as I am, but we used to describe the universe as a balloon with little galaxies on the surface, and the balloon expands and the galaxies all expand and so forth. Well, when Baade told me that the universe had suddenly changed from around 10 to the minus 30, 10 to the minus 30, that's a very small number, grams per cubic centimeter, we had jumped over the critical density. Today, the idea of the cosmical constant, we had jumped over from a positively curved closed universe where gravity was going to overcome the potential energy of expansion, and it was going to then come back and collapse on itself. Well, at that moment, as Bada spoke, I said, oh my gosh, we just jumped over the critical density, and now the universe is going to expand forever. It's going to be open forever. And I said, you know what? I told my friends and I told everybody for the next several years, it looks like the flat universe, which is today average curvature of the universe as a whole, is 0. We had jumped over that critical constant. I said, I am only using observational data here. I'm not a theorist. I do not understand how to formulate a theory of the universe as Einstein had. But I do believe we can say observationally the universe is flat. And it turns out I corresponded with Steve Weinberg years later, and in his book Cosmology, he says, yes, as he had said to me, yes, Bob, if the universe began flat, it would always remain flat. That's in the nature of the general relativistic expansion. So that's not a big deal, but it was for me at that time. And finally, the question of how irreversibility exists, why we are not in a reversible universe like Newton's laws, but we're in a law of irreversibility in the realm of entropy laws. That theory of irreversibility, I have published a paper on its origin based on the work in my PhD thesis on the absorption and emission of radiation, which Einstein had a famous paper on the so-called A and B coefficients, which describe the absorption into higher states and then the emission of a photon coming down from a higher state to the ground state. And what Einstein said, and this is a really dramatic, I think, in reading Einstein, it's in my 4th book, on which I call My God, He Plays Dice. And in what Einstein said was, when the photon is emitted, it must go off in a random direction. Otherwise, when we have lots of them, they would not become what we say, isotropic. Einstein said, in order for the universe, for a light wave, which he first studied back in his 1905 paper on the photoelectric effect, if a light wave goes off in all directions, it will be isotropic if they are also individual photons, which he argued starting in 05, if and only if they go off in a random direction, so that altogether, taken all together in the vast amounts in a real light wave, it will be a spherically symmetric light wave. So that basically is a theory that says that that randomness is the source of the irreversibility, and Einstein called it a serious weakness in the theory. And this, the rest of his life, he never was happy with the idea of any kind of chance. But Einstein, in my view, I think I've shown, had discovered chance in the universe, quantum chance, 10 years before Heisenberg. And Heisenberg didn't even know that Einstein had done that. So anyway, basically, I think I could wind it up right here. My work is on, as you know, my website. There's a personal story about me on the About page. The mind model is there, and entanglement is there, and for anyone who wants to go there. And John, thank you very much. It's just been great to have these people listening in on this. Thank you for all your attention.
It has been it is an honor, and look at how many people are here clapping and appreciating this disquisition, Bob, and amazingly how tight you managed to keep it all, give us all this time for chatting. So we have lots of hands up. I'm going to go to the hands thing, and we'll do it by we'll open up the queue here. So everyone who has a question, please throw your hand up in there. We've got 6 already. Jim, would you like to start?
Yeah, that was wonderful. Thank you, Bob. I just like how expansive it is, but also the clarity, and it really resonates with how I view things. As you know, I just have one minor thing I picked up on in your presentation, because you mentioned Schrodinger's book, What is Life, which is one of my formative favorite books, which I read years ago. It's a short book, 150 pages or something like that. It's not periodic crystal, it's aperiodic crystal.
That's right.
Oh, that's
Aperiodic.
good. That's good. That's a great
Oh.
correction. Absolutely.
Yep.
He already knew that it couldn't be one of a kind. I misspoke.
Yep.
Yeah. Thanks.
Very good.
Ken, you're next in line, sir. Ken Solis.
Hi. Thanks, Bob. I haven't seen you for a number of years, and
All right. It's good to see you, Ken.
it's good to see you. And thanks for hosting me in the past. I've continued to work on information and ethics, but enough of that. One other problem, or and one of the things I'm wrestling with in this book I'm writing is, and I don't go into great detail, is the origin of agency, which I think is philosophical and scientific, very, very challenging. But I wonder if anybody has thought about another possibility for free will, originating possibly somewhere between determinism and indeterminism via the findings in complexity theory with, I'm blanking on the name, but there's, when the number of choices increases using Feigenbaum's constant. Oh, I'm sorry, I'm blanking right now. But anyway, there's a range of choices that happens in complex systems rather than it being completely indeterminate or determinate. I have to know the neurological basis how that could happen, and I haven't worked on that at all. But I wonder if anybody else you're aware of might have ran into that. I'm sorry, I'll look up the technical term.
Well, Ken, in the last, just in the last year, that in excess of 100 free will models on academia EDU, a wild range of theories, and I try to write to everyone who writes to me about them, as I've done with you in the past. And I just think that the basics of having quantum chance, which is a key to the production of any new thing in the universe, is also applicable to the free will situation. So I would say, and that's in a way off the topic of Evo-Devo work today that we're doing about trying to understand complexity in the universe. But by all means, send me a note on your thinking about whether complexity somehow can generate some of those possibilities. Thanks very much, Ken.
Thank you, and I apologize for, I have it in front of me, but I'll email it to you.
Thanks,
Yeah,
that's great.
Please feel free to put on the list that citation, Ken. We're all really interested in that topic.
Oh yeah, it's logistic map. That's the term.
Logistic map.
Yeah, logistic map and it's a very simple math equation. And if you do the math, you quickly run into these numbers that go from just one value to 2 to 4 to 8, and then eventually becomes chaotic beyond a certain point. So yeah, thank you very much.
Jeff, you're next up, buddy.
Yeah, thanks, John. I wanted to say thank you very much, Bob. Very inspiring, and I have a lot of reading to do on your website.
Great. I love it.
Well, philosophically or epistemologically speaking, I wonder if you might touch on the role of the observer in terms of information, entropy, meaning, and so on. I think you talked about the limited but not zero information of the universe at the Big Bang region, and when I heard that, I thought information. There was no observer. But in the sense of Shannon information, yes, it's related to complexity. Just wonder if you could talk about the role of the observer in these various terms as you see it.
Yeah, the observer is really a wonderful question. And in my, I'm see if I've got my screen here. Wind me down, and I'll just go to quantum. And maybe I need to reduce the size of this page just a little bit, so you can see all the, I switch to entanglement. Under the drop-down menu, I've got to reduce it a little bit more. You'll see, again, quantum. You see way at the bottom of that quantum drop-down, Jeff, you'll see wave-particle duality. And wave-particle duality is basically a question of how some think, including some terrifically great thinkers, think that the wave cannot collapse to be a particle without the conscious thinking about it when making a measurement in an experiment. You're familiar with that whole idea, Jeff, that the observer is the one who,
I'm not sure how to frame it in the quantum domain. I was thinking more in the larger scale epistemological domain, but maybe you're going to tie the two together.
Actually, they obviously are connected. The ability of us as scientists as to observe the universe, it's just phenomenal, the scale of things we can do, from the incredibly small to this new wonderful Webb telescope, where we can see right to the basically beginning of the universe, or the earliest few 100,000 years. So observer and doing experiments and getting results, and the results are turned into numbers. Information is the whole idea of what it means to be an experimental scientist. So beyond that, that then, of course, as a philosopher, is our source of knowledge. And all the way back to Aristotle, they based Aristotle, who really was a very sensible empirical scientist. He's attacked for years by those who went on to our modern Renaissance thinking, but he was a terrific thinker, and he really was a good observer of things around him. And really, it seemed quite reasonable to notice that things have a tendency to drop to the ground, and he develops a law for that, and other things tend to go up and so forth. That was based on his observations, Jeff. So
yeah, they do within that context.
And they did work for him.
Yeah. All right. I have a lot to learn. Thank you.
Okay, Bob Ulanowitz, you're next, sir.
Okay, thank you, John. Bob, a wonderful lecture, and what I really like is the way you structured it and emphasized your contributions to all of this. So, to save time, I'll just emphasize two things that I think I may have contributed, and some of it overlaps with what you said, some of it discords with. The first thing, I tend to be heterodox about a number of things, and one thing is entropy. To me, entropy is nothing, or more grammatically correct, it is nothingness. Okay, if you look back at Boltzmann and Gibbs and so forth, what you find is that they are describing the lack of constraint. They're talking about an ideal gas, in which there are no internal constraints in the gas and so forth. And everybody's taken that formula to epitomize entropy, but it is entropy in only one very special case. The world that we live in, there are a lot of conditional constraints. And when that happens, you can then parse out the Boltzmann-Gibbs entropy into two terms, one of which is entropic and the other of which is average mutual information. And they differ, I believe, ontologically in terms of their causality. I believe, for example, that entropy has no positive causality. Positive causality is caused by things that are positive, like momentum, mass, matter, and so forth. What entropy does, and you described it well, is create phase space, okay? And it allows positivist agencies to act. So that's, it's heterodox, but it all fits together very well in my own mind. Maybe somebody can convince me otherwise. The second thing I would like to sort of mention is autocatalytic centripetality. Okay, if you follow the argument of autocatalysis and self-stimulation, if you will, if you have a random event where one of the actors brings in a new resource, that will be rewarded, okay? And it will be shared by all the rest of the members of the autocatalytic loop. So that in the end, what you have is an autocatalytic loop essentially aggregating resources it needs to continue to function. Now, the centripetality, then, I think it speaks, for example, to consciousness and whatnot. We have all of these feelings and thoughts and so forth, but they all tend to focus on some virtual center, and that virtual center is the ego. and what's his name? Not Bernard Lonergan. Who? Okay. Anyway, this very, very famous philosopher said that the chemical imperialism, which is another form of autocatalytic centripetality, is the primary driver of all of evolution. That you can cast evolution as constraint, mutual information, that which holds it together, and it doesn't have to be active, but it can. It obviously can be, and apophasis, that which is not. In other words, this newly created space, phase space, actual space, and it becomes a dialectic where you have an increase in one can cause a decrease in the other, and vice versa. So they're antagonistic.
Are you referring to Bertrand Russell by chance?
Bertrand Russell, thank you, sir.
Oh,
exactly. Yeah. He made that observation sometimes in the 60s, but it was sort of forgotten. But then I picked it up and I thought, yes, he's right. Yeah. And I don't agree with Bertrand on a whole lot of philosophical issues, but he was dead right, I think, there. Anyway, yeah. I'll keep it at that and let it back to everybody else.
Okay. Quick remark, you said that entropy seems to be a causal force. I think of forces more down at the atomic and molecular level, but I've read all your works, Bob, and I'm glad you're happy with your webpage about my webpage about your work, and I'll be continuing to follow you. So thanks for that.
Okay, the causality is different ontologically. For the positivist world, it is actual make things happen. It's the basis of agency, which I believe. I'm sorry, who's working on? I got to Ken, I guess, is working on. That's a big thing in my lexicon too. It's active agency, things that make things happen, versus passive agency that allows things to happen. And they're ontologically two different types of cause.
Yeah. I'm not sure I can give you any more feedback on that at the moment, Bob.
Okay. Thank you. Let's Pushkar is next, and then Charles, you were actually next, and then you dropped down on the. Can you go next, Charles? It looks like Charles has maybe some kind of difficulty. How about Pushkar? Would you?
I'm here.
Oh, there he is. Hi, Charles. Can you go next?
John. Yeah, sorry, I had clicked the hand up button twice and it pulled me back down. Thanks for noticing. There's a statement, perhaps, and a question. The first statement is, as a newbie to this field, I mean, I've been reading your emails, John, and so on, this group's work. This is not my field. My only claim to fame is knowing Serge Haroche from my university days, and Alain Aspect, because that was at the university where I was studying, and my minor was quantum physics, but that's, last century, right? So that's the amount of recency that I have in my knowledge. So, Bob, this is absolutely amazing. And John, what I keep thinking every time I hear or listen to these things, that you guys have so much background that you're able to make implicit connections between the levels of abstraction at which you're functioning and more, let's say, granular things like Shannon theorem and so on and so forth. You're making these connections, and what I'm always missing, perhaps that's my engineering mindset, I'm always missing is, why and how are you making these connections? You seem to jump very comfortably saying, and therefore Shannon applies. I'm like, okay, why? So I'm missing that knowledge layer. Perhaps it's just not being expressed clearly for me. That's number one. And then the clearer question, rather than more a statement, isn't non-deterministic worlds necessarily destroying causality, or the two are orthogonal? And I'm mixing the two.
Well,
great
Charles,
question.
Okay, good question. The non-determinism basically just changes the simple deterministic causality that says the entire universe is doing what it's doing from time zero under the control of either a Newtonian law or an omniscient, omnipotent God. And what the indeterminacy does is open up possibilities. And so all of my work is turned around the importance of genuine possibilities that are out there in front of us as we think of things we would like to be agents to do and freely do, okay? And I transfer that all the way up to the universe as a whole and in this cosmic creation process. So in terms of making connections, I'd like to just, if I had a minute or two, let's get through the questions, but John, leave me a little time. I'd like to drive you around my website a little bit and show you the thousands of connections between my hundreds of what are drop-down menus on concepts to over 500 thinkers on the left-hand side here. And what I've been doing basically, and coming back to Charles too, making connections between things is to me the way of learning about things. And I always want to go deeply into any particular thinker. I've spent my time, I've got a massive library. I see John has a big one behind him too. And I've read so much and tried to take what I've learned and put it onto a website, which is free and open to anyone to read. And I've published 5 books. The books are on Amazon, but I don't need the money. It turns out there's another side to me where I've been an entrepreneur and invented a number of things and made quite a large amount of money. And that enables me to freely give away all my books, unlike those who in academia have published a book and worked for years to get it. They want to sell it for $100 or whatever. My books are on Amazon for sale, but they're also all freely available as interactive PDFs. And although my books are all in black and white print, my PDFs are in color and they have animations, many animations I've made of things happening like particles colliding with a photon and why they lead to an indeterministic irreversible event and so forth. So when you said connections, I feel like my website is a mass of connections, but I hope you can travel around them and you can navigate through every thinker off to their concepts, and then from that concept to other thinkers who thought the same thing, and come back to concepts. And I have a lot of young people. I'm basically teaching. When I taught at Harvard, I had 30 students. At the end of the semester, they were gone. But now I have quite a large number who are writing to me, reading me, and basically I have them indefinitely as a result of this website.
Thank you.
Yeah.
I'd like to say before, I know Pushkar's next, but this is the book we're reading in our book club next. It's a Paul Davies book, and it is a trade version of the 2 books that Bob Doyle showed at the beginning. The 2 much more technical books, Information and the Nature of Reality, and From Complexities of Life. This is a simpler, shorter version. And it starts, Charles, with this thesis that the information webs that life produces are kind of the missing ingredient for understanding the origin of life. So we're going to read this book and go through it. I'll post that. But this could be a wonderful, maybe entry level, in addition, of course, to Bob's amazing website. I'm just going to throw that up.
I will get it and read it, and hope to join you, John. Thanks.
So Pushkar, you're next, sir.
Sure. Thanks, John, and thanks, Bob, for the wonderful talk. I could not hear much of it. I was kind of traveling and doing a couple of things, but thank you so much. And from what I heard, I had a couple of questions, and one of that was that when we are speaking of the free will, the free is all right, but the fact that we are talking about the will, so does any of your theories or works, let's say, elaborate upon that? What is this will about? I mean, what's the purpose which is underlying this will? So does the universe have a purpose from where we draw the will? And secondly, do you allow for a universe where there is no cause required? A universe without a cause, is that somewhere possible in your work?
Okay, well, thank you, Pushkar, for that. As to what the will is, it is the essence of what we think of as agency, that we are people, we are organisms, and in my model, the very earliest living organisms, single cell prokaryotes or bacteria alone, for example, have an agency. They may not have much in the way of possibilities, right? A little bacterium with a flagella winding one way, they travel a straight line. And along their bodies, they are sensing the temperature gradient, maybe a gradient of food or toxicity. And basically, their will consists of being able to decide this is not the right direction, in which case they turn the flagella the other way and they tumble. And there's randomness. It may not be quantum, but it's definitely randomness. And then they start going forward again. And if they find that, wow, this is much better, this is more tasty, more warm, I'm going in this direction. So agency starts right at the fundamental smallest living things, as I see it. And basically, they need possibilities. That's the first step. And then they can take one which they measure, that they notice what's happening, and they change to another one if they're not in the right direction. Does that make sense?
Yeah, I think I'm trying to understand what you said.
Thanks. I'll show you one thing, John. I have this wonderful camera. Let's see if it'll do it for me. Oh, no, it's not working. I will ask the camera to follow me. I put my hand up, and then the camera can take me anywhere I want to go in the room. And basically, I can show you around my room. I'll sit down back at the desk. I've been a big study of filmmaking technology back in the day. I had a company that had thousands of people learn to make movies with my tools, and in recent years, video, and the latest, greatest state-of-the-art in podcasting technologies. Another small thing, the first podcasts ever made were made in 2003 in my lab here at Harvard. And there's been trillions ever since. If I'd made even a millicent, I would be way more wealthy than I am. Okay, let's get back to questions.
Yeah, so Julian, you are next, sir.
Okay, well, as some of you know, my obsession is cosmological natural selection, the idea that our universe evolved is the result of an evolutionary process, Lee Smollen's old idea. And I was wondering, have you ever engaged with that? Do you think that relevant to you?
Could you just repeat, Julian, what it is you're wanting me to think about, please? Repeat.
Cosmological natural selection, the idea that the universe might have evolved, but that universes might reproduce with variation. And so you get Darwinian evolution of universes. It's an old idea of Lee Smollen's that's been
Lee Smollen, yes,
on
right.
over the years. But in a way that seems to help you a lot with a lot of what you're doing in your work. And I'm just wondering, have you engaged with the idea of an evolved universe? Because then you kind of have a...
Yeah, I'm familiar with his work, and David Laser.
Agency through an evolved process. It stops the kind of life abiotic like divide, and it just says, abiotic life is fine-tuned by evolution to come to life. It's already got information in it from the evolutionary history of it, and that in a way I think makes your arguments easier to and stronger. I just wondered, had you engaged with the idea?
Yeah, the precursors of agency are already present in the abiotic world.
Yeah.
Yeah, exactly.
That's certainly the work Paul Davies is working on, and many others. So I'm familiar with them, but I don't see the need for a purpose outside of the universe. But John?
Yeah, so I would like to reformulate what Bob and Julian just said from a third perspective and ask if this helps. The way that Peter Corning talks about teleonomy, for example, entrained purpose in a replicator. My wonder to you is, if the universe is a replicator, if it is an autopoietic system, then there seem to be three at least clear purposes, three teleonomies that are entrained in such a replicator. One is conservation of the replication. Another is poiesis, which creating, exploring possibilities, which would be your freedom, right? So one is the will of being able to stay on this deterministic cycle. Another is the indeterminate exploration of possibilities. And then the third is persistence, which, Addie Pross and many of us say. Adaptiveness in a community of other replicators, which are going to compete and cooperate with you. So it feels to me that if the universe is such a replicator, then as Bob said, there are these three teleonomies encoded in abiotic systems. And we can look at a Bernard cell and say, well, it does appear to have these three teleonomies. It has stable replication, it has stochastic exploration within the Bernard cell, constrained randomness, and then third, it persists, right? Against other uses of the local resources. And so I wonder if that teleonomic approach, I wonder if you would consider that there is freedom. So is will on a continuum? That's the idea, right? That's the question. Is it still on this continuum? And then your life thing becomes like the big jump is when the encoding now becomes internal with the aperiodic crystal. The big jump, right? But last thing I'm going to say. I looked at stars and their replication cycle, and I started thinking of them autopoietically, and I realized that the three populations of stars have been building out increasingly complex periodic tables, and those periodic tables are kind of a rough analog to genes, because what they do is they change the initial conditions of the subsequent replicator and the dynamics. And so they're encoded, if you will, in the environment or in the whole system. They're not tightly encoded inside of a boundary. They're in the entire system. And yet there is an encoding. I think you could argue there's an indeterminacy, because each star is going to, in a POP3 or POP2 or POP1, is going to have a different combination of those elements, right? It's stochastic. But then there's also a predictable nucleogenesis cycle. So that's my question is, can you say there's an agency there, even if you have to put question marks around or quotation marks around it? Is there those three agencies: persistence, exploration, stochastic exploration, and predictable cycling?
Is that to me, John, or to Julian?
That's to you, sir.
Sorry. So did you call it a periodic table?
Yes. So I was thinking of the way the elements in the periodic table are built out in the three major replications of the three major population types of stars. You can think of them from this exploratory. They're going to explore the possibilities that physics allows at the elemental level, right? High energy physics. And then you can think of them also as conservative and predictable in their replication, right? That supernova is going to create the shock wave, and then you're going to get this predictable next cycling. And then they're also persistent. The third thing, they're out competing other uses of star stuff, right? Okay. So I wonder if that feels to you harsh, the way Bob was saying, right? That they're in the abiotic systems. There is preconditions for the emergence of life. Bob, maybe you want to jump in on what I just said. Is there anything else that I got wrong there? Or?
No,
I think I know you. This is Bob Jelanovich. Yeah, go ahead, Bob.
Go ahead, Bob.
I guess he wants me to say something.
Well,
I would just say one more small note. The periodic table, just Google Bob Doyle periodic table, because I have a way of teaching the periodic table that has taught a lot of people chemistry in an absolute whiz, including one who was my younger sister who was failing chemistry, and she aced the class as soon as I produced this periodic table diagram for her. And another is a nephew who became a PhD in chemistry at Berkeley, went on to work at DuPont, and moved up in the company until his last there was as CEO of DuPont. So I suggest to you my periodic table at Bob Doyle periodic table. But the steps you described, John, yes, they are interesting, but I don't see a star as spawning other stars, right? I'm trying to see the picture in which you see the star, the supernova phase, and then other stars will form out of dust and gas, but it's almost exactly the same as the beginning of the universe when we have nothing but atoms and not even molecules yet, and so forth.
Julian, you can jump in.
I would say that they do build each other out. Okay, so what's happening is first round of stars, you've just got hydrogen, helium, and then they start to build out the bottom of the periodic table. But when they get to the end of their life, the supernova explosion lifts all of those newly forged elements from the bottom of the gravity well, distributes them out into the interstellar medium, which is being fed fresh hydrogen from the filaments into the clusters and so forth. So it enriches that gas. So the second round of stars that form after the first round are already enriched with metals, with a bunch of elements. So they're able to forge a lot more elements. The periodic table gets built up. That second round of stars, supernovas, again enriches from the bottom of the gravity well, distributes those forged elements out into the interstellar medium, into the hydrogen. Third round of stars, and you basically, they are essentially building out step by step in a really directional process the full periodic table. So you get planets like Earth around third or fourth generation stars. You can't get them around first or second because you haven't built enough of the periodic table yet. So you can see a kind of a circulatory system that allows stars to, in 3 or 4 rounds, build out the full periodic table required for life. And it looks very directional. It looks very teleonomic. It looks like the kind of thing you get in an evolved system if the universe were the unit of selection.
If I may comment on John's description, I like your description very much. It consists of 3 elements. I've defined in my own lexicon 3 elements that are the members of the evolution. Number 1 is law, determination. Number 2 is contingency, which is more than just randomness. And number 3 is agency. And I define agency in a very elemental way. It's the ability of a system to choose or concentrate on one element of a large random sequence of things that are presented to it. And those 3 things come together very nicely, and I think John was beginning to get onto it to describe evolution. I'm going to have to run soon too. I'm sorry.
Wow, this is a really rich discussion. I wonder, Jaegers, your concept of closure. I wonder if you want to jump in and give us some thoughts. And I don't know if Bob is aware of your concept of closure, because he has written a whole lot of stuff, but I have not seen your stuff on his website. I wonder if you could ask how you think this might apply to the discussion we just had.
Yeah, thank you, John. I have the wrong name actually indicated at the bottom because I'm at my daughter's home at the moment. So I'm married. My name is, of course, Gerard.
Gerard.
I think, yeah, I studied Bob's website the past 3 days, and it's enormous. And it's also enormously interesting. So I will study it several days more, I think. And the list of 500 philosophers is to be done in a year. I think I can't do that soon. Right. So it will take a lot of time to do that. Yeah, and then I was actually intrigued by the 2-stage model of evolution, in the sense that the first is, for me, a bit like variation, if I talk from it from a biologist point of view, and the second is a bit like selection, and they are both true. And I wrote a book myself last year, which took me 4 years to do. And there I discuss evolution first from a biological point, and then I try to generalize that. And if I generalize it, I'm very close to this general variation and general selection aspects. So I think there's a way to connect to Bob Doyle. Thank you for that. So that's really nice. And what I add is a third law, I would say, because I think variation is a law. If you reproduce in a not very exact way, you get variation. And if you have variation, then when it's exposed to an environment and not all the variations experience the same pleasure in that environment, they will be sort of sifted out for doing better or worse. So that's selection. And both of them are very lawful in the sense that if you have that process, it will always turn out into variational things and into a selection of them surviving. So that to me are two laws of evolution. And they are also laws of biological evolution. And I think you can find them to a certain extent in physical evolution. So the extent to how much you can find them there is an interesting question. And if I then think about the third law, for me it started in biology. If you start with bacteria, and then you have two choices. You can either link them together and create a multicellular bacterial unit, and it's only multicellular for me when the bacteria create plasma connections, because otherwise they're just lumps of cells, not a new organism. And this is something that is hardly ever noticed in science, because very few people consider plasma connections definitive for the organism concept. So from a bacterium, you can go to multicellular bacteria or to what they call eukaryotic cells.
Right.
But there's a problem with the word eukaryotic, because the carriers is something that only arose after endosymbiontic cells entered into a cell, so that you got an endosymbiontic, what I call a host cell. And then if host cells divide, many of the known eukaryotic cells actually degrade their carriers before dividing. So from a more classification point of view, you are not a eukaryotic cell at that moment. So that's why I don't use it. So I prefer the term host cell, because the endosymbionts did not go away. So that then there's another step from eukaryotic cells, if I call them that way, to eukaryotic multicellularity. That's all the plants and fungi and that sort of things. And then from there you can go to the neural network as another closure, because I speak in terms of dual closure.
Yep.
And this can be brought back to molecules and atoms and hadrons.
Yep.
So then you have what I call the operator hierarchy.
I see. Gerard, we have only 5 minutes left, and Julian asked if we could let Bob show us around his website just a bit more.
Yeah, very good.
Yep. Thank you, sir.
Yeah.
Bob, do you have a few minutes left to do that?
I certainly do, and I'd like to teach them how to use it. And I'm only going to live about another decade if I'm lucky, and I need people to take over this website. I have a number of people who are saying they're willing to do this, keep it alive. I will fund it with my institute and my savings at the moment. I'll show you. Let's see if I can find it here.
Well, you know that we would be honored if there's any way we can play a role at our institute here. All of us directors have talked about your work, so.
Yeah, let's talk about that. Let me see if I can. I'm sort of stuck. What I'm showing is the wrong thing again because of my multiple screens. I don't know if I can do this.
Yeah, you may have to unshare screen and share again. Yeah.
So where do I do that? In the screen, stop sharing.
Yeah. That little.
There
it is.
I got it. And then share a screen and find the one which is. Oh, I'll show you this one for a moment. See if I can get this to come up. Share. And there it is. So this is when I got my PhD, first thing I did was work with NASA as the executive secretary, designing space missions for the next 40 years. And it was a great experience. I was the secretary meeting with a board of top scientists in the country for 2 years and 6 subpanels. When I came back from that experience and we started spending many hundreds of millions of dollars based on that report, I became worried about how it is you make money, how wealth is created. So I started a business, and that did well, became $1 million business, but never made any money. But then my wife, Holly, and I, who also got a PhD in physics, we built 25 game prototypes for Parker Brothers, showed them to Coleco and Milton Bradley and Mattel Electronics. Ultimately, Merlin, which some of you, depending on your age, may remember this game. If there's a hand up from Julian, we sold 5.5 million of these games in 13 languages and made enough money for me to be independent for the rest of my life, basically. And so I wanted to show you a quick look at that. But now let's go see if I can somehow change us back. I'm going to say stop sharing and share again, and ask this time for just the website itself. And come on, there it is. Do you see it now? Good. So it just starts off saying how for 25 years I've been building this website using a web publishing system of my own design. Among the entrepreneurial things I did was I was licensing some technology to Steve Jobs. And when the Macintosh came out, I became the 11th certified developer to write software for the Macintosh. And I wrote a desktop publishing program, the very first desktop publishing program to lay out my books. Now, since then, I sold my desktop publishing program to Letraset, who wanted to be in this business of desktop publishing, and I went on to invent those other things. So I then built this web publishing system, which is absolutely unique. It was suggested to me by Tim Berners-Lee, who was upset that websites that he wanted to use again had disappeared off the website. He wrote a proposal for the W3C Commission saying, we should have a persistent archive that just basically saves all the websites, all the out there. So I built this website with his ideas, and I now want to drive in it a little bit, but I'm actually stuck here. I'm still with a problem. Is this the site? There I am moving it a little bit. This looks good. You see, I've shown you my drop-down menus. These are the concepts that I've studied and then connected them to these hundreds of philosophers. So we can go round and round. I've also wanted to draw your attention to, let's go down to the bottom, my presentations. One of the big things I managed to work on with, let's see, I've run off the bottom. These are, come on, Bob. Here we go. Here are my presentations. I once met with Terry Deacon, who invited me to his meeting at Berkeley on biosemiotics and information philosophy. I've been reading. His conference was called. Don't see it there. Anyway, this is the way I used to make presentations like this one. Growth of information in the universe. See if that will come up. Here's that story. You've seen that already. Now I have an ability to move through the slides. Lord Kelvin's heat death, the growth of information. I presented this at, here's the Big Bang of the universe with the early states, and then my cosmic creation process. I presented this to Terry Deacon, and basically, he got tangled up in a charge that he plagiarized from Alicia Guerrero, and I managed to get the Guerrero book, read it, make a study of all of her references, all of Terry's references, put up a spreadsheet, mailed it to the investigating committee at University of at Berkeley, I guess, and he, as you know, he was exonerated. So I wanted to show you, let's see if I can go back now.
Thank you for doing that. I had lunch with Terry last week in Berkeley.
Great.
And I had no idea. I didn't know you. If I'd known that you and he had this connection, I would have told him about this this meeting and got Terry to turn up. Yeah. But
Thanks
anyway,
for that.
thank you
It was fun.
thanks for clearing it.
What I try to do is really find out how people think, what they work, what they've done, and put it on here in a way and teach it at the same level I used to teach in first year, second year science students at Harvard. So everything I've written, I think, can be understood by a smart high school student, and anyone who wants to explore an area they'd like to go into research, they could probably find an introduction to it on this website. So I want to show you a little bit more about how the website works. For example, if I hold down a shift key, well, let me first hold down the @ key. You see what happened to the top of my website? The website now has a clock on it, and I can change that date to any time back for the last 25 years and see the way my website looked. It would have only hundreds of web pages, but they'd all be there the way they were written then, showing what I thought then and how my thinking has changed over the years. Okay,
Nice.
that's a unique capability based on
That's
Tim Berners-Lee's
amazing.
notion. Yeah,
That's incredible.
so let me do another one now, though. So let's also just hold a shift key. Anyone who wants to learn my website technology, which if I had decided I hadn't made enough money yet, I would have sold it. In fact, I did sell it for a short time. One of the first groups that bought my system paid me $70,000 for it. So I could definitely have made a living publishing this timeline system, but I didn't because I had already made so much with the games. So now I'm going to say shift click on the text anywhere, and look what opens up. This is what you'll see, and if anyone wanted to become an editor on my website, I would give you permissions, and you could log in like I'm going to do right now, and then I would click it open, and it says, this is the index root at files root. This is the main page, and that means that if I look at the series manager, come on, series manager, you could see every version I've written going back for 20-some years. Okay, and look at any one of them and bring it up as its own web page. Okay, so
Bob, I'd like to
That's
suggest
amazing.
that several of us would be willing to be editors. If you would like some editorial help, like Jim Kaufman's point of aperiodic versus periodic, we can go through and fix little tiny things like that if that would be helpful to you. Anything, because I think this is just fantastic. Just keep us in mind if you'd like some folks in redundancy, right? People who are on your team. So.
Yeah, I definitely need someone because there's going to be a day not too far off when I won't be here. Yeah. So I've shown you the fact of the website tool. And I just wanted to point a couple of other things, and let's get back if I can to.
How about we wrap up at 1:40?
Oh, yeah.
3 more minutes. Does that sound good?
That sounds great.
And you know what else, Bob? I bet you many of us would like to have another one of these sessions with you.
Yeah, I would like that. I'd like another tour, like we could do a half-hour tour as a separate thing sometime, because this was really interesting, and I feel there's a huge amount of stuff here I would find useful and interesting, but I'd love to help in navigating it. That would be great.
Yeah.
Well,
okay, why don't we do that, Bob, if that's okay with you?
I would love to do it because I'm looking for people who might keep this thing alive in the future.
Good. So we'll have a specific thing, and we'll give it up to an hour, but it'll be at least a half an hour of you touring and then us figuring out how we could help.
That sounds wonderful, John. Or any of you who want to be interested, I'd love to talk with you at that time, John. Thanks for making that possible.
Absolutely.
I think there's a huge overlap between what you've been doing and what John and the others have been doing at the Evo-Devo Institute. I think there should definitely be some kind of communication here, because a lot of your work would be hugely valuable to the community here. And yeah, we definitely need a conversation, I think.
Thanks very much, Julian. And John, maybe we should wrap it up.
Sounds good. You want to give us some last words for posterity for when we put this on our YouTube channel? What do you want people to really think the most about with respect to information and life and human values, meaning, purpose? Where do you want us to go with this brilliant history and set of insights you have built over the last 70 years?
Well, it's really hard to wrap in such a short moment, but the most important thing, I guess, is that I have loved what I've been lucky enough to do. I've been so privileged, really. I grew up in a segregated housing project in Providence, Rhode Island. Black students in my school had to live in a different part of the place. It was a federal housing project. We have come a long way, this country. And I was blessed to go to a wonderful high school, classical high school. They teach Latin, Greek. I didn't do Greek. I did Latin. I did German. I went to Brown. I did French. I did Russian. I've since then done 11 languages. I got invited to speak in Japan, and I studied enough Japanese to open up with a 10-minute description of my work in Japanese. My son came along with me. He got married in Japan and loved Japan. I've had, as I say, a blessed life and great opportunities of all kinds. So what I want people to know is that I've done my best to tell my whole story on the website. So when I'm gone, I also have 50 lectures on, let's see, I'm on the home page here. Anyway, I have 50 lectures on YouTube. I hope to start doing them again, but in a more interactive way. Maybe, John, you are doing what you do in this mode with a Google Meet or Zoom or whatever, but I will restore it in a way in which I will have guests in the room with me in Cambridge. I've just bought a website called metaphysicalclub.org, and I hope to restore Charles Sanders Peirce and William James and Oliver Wendell Holmes, great metaphysicist. And you should know I've written, one of my 5 books is called Metaphysics, because everyone talks about metaphysics, but I don't know too many people who kind of really know what the nuts and bolts of it are in terms of the identity problem and all kinds of things. So I've written about that. So I've done my work. I've been very, very lucky, very happy, and I'm pleased if it lasts out there and produces more students. I love the students at Harvard. They were incredibly smart, but only 1 or 2 of them have been able to follow me, and I've been able to follow them. Whereas now I've got literally hundreds of people who are kind of benefiting from what I've done. So thank you for helping me spread my word, John. I appreciate it.
Well, thank you. It's an honor and a privilege for all of us. And we really appreciate what you're doing and the inspiration that you give us. So much of us of what we're doing is on these same exact questions. And it's amazing to see what you've been able to accomplish. So thank you again. And thanks everyone for the wonderful questions. And I look forward to the next meeting when we're gonna, go more into your site and
great.
Thank you everybody.
Thank you so much, Bob. That was fantastic.
Thank you all.